Hi, I'm Julia Schottenstein, and I'm a product manager at DBT Labs. In this talk, I'm excited to share with you more about DBT and how we enable data transformations. If you're not there already, head over to Discord, where I'll be answering questions live. You can also use this QR code to link to the channel. You can find me on Twitter at j_Schottenstein or email me at julia.schottenstein@dbtlabs.com. We just heard from Nick about how to use Dagster to enable orchestration. And now we're going to talk about what happens once your data has been loaded into your warehouse. Data in your warehouse is often still not in a useful shape for the business. You'll need to transform it to meet your team's needs, and that's where DBT comes in. DBT Labs was founded to solve the workflow problem in analytics. We created DBT, our product, so that anyone on the data team can model, test, and deploy data sets using just SQL. We have an open core product strategy. DBT Core powers the transformation, testing, and documentation. And we also offer DBT Cloud, which is a proprietary product to help teams develop and deploy DBT models with confidence and ease. I'll be talking about both in the demo a little later in the talk. So you might ask, what is happening in the data landscape that makes DBT more relevant than ever? The shift to cloud data warehouses changed the way transformations could be done. Data transformation used to be a lengthy and resource-intense process. Storage and compute for legacy data providers like Postgres and SQL Server were expensive, meaning most transformation had to take place before data landed in the warehouse. Cloud warehousing made storage and compute cheaper, which allowed transformation to happen in place. This shift from ETL to ELT is well talked about, but it created space for DBT to fundamentally change the analytics workflow. Now, data engineering teams don't have to decide what data is worth keeping because of cost and resource constraints. You virtually store it all in the cloud and let those closer to the business priorities decide how they want to model and shape the data for their needs. There are two predominant ways transform is done today. The first is with traditional ETL providers that offer a GUI interface for massaging data. The second option is custom Python code and orchestration. While both these methods have their strengths, they both share a common problem. Both methods require highly trained and hard to come by individuals to manage the data transformation process, which is not only expensive and hard to scale, but creates a workflow bottleneck. Those who can express business logic don't have the tools to do the transformation themselves. And these analysts become reliant on the smaller, more specialized group to produce clean data tables that they can then analyze. This ultimately makes the data workflow process slower. Lots of back and forth requests, a lot of miscontext, and the frustration of getting the data in the right shape often leads to teams giving up prematurely and settling with less than ideal outcomes. DBT solves this frustration and fixes the data workflow problem. SQL is the language of every modern cloud warehouse, and it also happens to be known to analysts and engineers alike. By creating a solution that leverages modular, portable SQL, we're making transformation both faster and more accessible to more people on the data team. More hands, lighter work. But it's not just who is transforming data, it's how. With rigorous testing, version control, continuous integration, and automated documentation. These processes are critical to ensuring data code quality and scalability. Software engineers have been working like this for years. We just made these principles applicable to data. And so while transformation is at the core of what we do, we're a platform that lets you develop, test, document, and deploy your data models. We push all compute down to the data warehouse. Why is that so important? Our architecture is way more secure because data never leaves the warehouse. And two, with transformation in place, no added network latency, you can expect faster operations. We're also heavily investing in metadata because anything and everything you'd want to know about your data is exhaust for DBT. We want to use the metadata exhaust that DBT generates to help data teams respond to data incidents, understand provenance for data sets and their use cases, address performance and quality improvements, and more. As the producers of these data sets, we are in a unique position to both observe how logic is changing and how data is changing. As a result, there's a lot of context and insight we're able to provide both data teams and data consumers. dbt's development framework promotes 4 key outcomes. The first is collaboration. At the core, we believe in version control and documentation, allowing for smoother handoffs and teamwork. Velocity. With dbt Cloud, we handle all the deployment for you. Focus on analytics and use cloud to ship data products faster. Quality. Testing is done right alongside code development. Never make quality an afterthought. And finally, better governance. We help teams standardize processes and control access to simplify compliance. dbt promotes a new way of working. It empowers data teams to move faster and more reliably with some simple frameworks and guardrails. Congrats, you're now an analytics engineer. These are the humans operationalizing the data workflow. But don't just believe me. This is what one of our customers, HubSpot, is saying. We think empowering analysts to own their tools is the only way to build a productive analytics team at scale. dbt makes it easier to do data modeling the right way and harder to do it the wrong way. Okay, enough pontificating. Let's see dbt in action. We're going to head to the demo with an example e-com shop, Yukon, that we've been referencing throughout these talks. Okay, demo time. So what we're going to actually do now is build some dbt models so you see how you can do transformation in some of the analytics engineering workflows with dbt. What we're looking at right now is a dbt project in our cloud IDE. So our dbt cloud IDE is a purpose-built IDE that makes developing dbt really simple. For this demo, we're going to be working on our Yukon shop, which is a fictional e-com company. And the first thing we want to do is really get familiar with their data table so we know what we need to transform. Okay, so let's take a look at some of the base tables that we're looking at. So we have a users table called staging users, which is pretty simple. It's user ID, first name, last name, email, language, activated or not. We have a purchases table, which is going to link a purchase. It's going to create a purchase ID and it's going to link a user ID with an item that user purchased on an order date and give it a state of whether it's successful or not. And then finally, we have a staging items table, which just is going to give a little bit more detail about the kind of items that you can purchase from Yukon. So it's an item ID, category, and the price. So these are our base tables. We have very light transformations that are happening here, like a rename of a column, but it's pretty close to the raw data. Let's look at our lineage tab. This is one of the great features of a dbt Cloud IDE. When you're developing with data, sometimes you can get lost in the DAG. You forget what models are downstream or upstream from the model you're currently building. And this helps you orient if you're creating a new model or editing a model, where exactly you are in the DAG. So we have this customers table. Let's take a look at that. That's actually a little bit more of a complex table. And it takes in the 3 tables that we just described and does some transformations. Okay, what's going on in the customer table? We have a user ID, first name, last name. Then we have a first order, the most recent order, a number of orders, and customer lifetime value. We can see here in the code, what's happening is dbt starts pulling in our base tables, their staging tables, using this ref function. That really powers a lot of the DAG creation in dbt. It's a Jinja function, which basically says the table I'm building right now references these upstream models, staging users, staging purchases, and staging items. And then it does some transformations looking at min, max, and count of the order dates and purchase IDs to create these new column names, as well as aggregating all of the prices for the purchases that you've made to get a total amount, which is your customer lifetime value. So that was a really quick overview, and we're going to actually create a transformation together so you get a better feel for how it all works. Okay, you can see right now I'm on the main branch. At the core of DBT is version control. And if you're new to Git, DBT Cloud's IDE makes the workflow around Git really simple. So it gives you guardrails, so you practically can't do anything wrong. So we're going to create a new branch. One of the tables I think might be interesting is looking a little bit more on what our most popular items are. So we're going to create a new feature branch called feature items purchased. Now we're on a new branch that we can do our development work. And in our DBT project, this is our models table folder where all of our models sit. Staging is the base tables, and the more complex tables, we can add them here. So let's create a new file, and we'll call that items purchased .sql. It's a SQL file. Okay, the first thing we'll want to do is pull in our upstream models that this model will rely on. So let's pull in the items table using that ref function that we just described. Curly brackets means I'm referencing Jinja. Okay, that looks good. Now we want to pull in our purchases table in the same way. Okay. And now we're going to do the actual transformation. So we're creating a new table. We'll call it items purchased. And let's select the columns that we want to show in this table we're building. So we'll want to pull the item ID as the unique identifier. Let's also pull the category for the item. And let's pull the count. So the number of times that this item has been purchased. We'll call that column that we just created total number purchased. And then let's pull in the sum. So the total of the prices, so we know how many times, how much it's been transacted. We'll call this total amount purchased. Okay, and we're calling that from the items table. We're going to join that with the purchases table on the item ID. Item ID. I just realized another mistake I had here. Okay. And the last thing we want to check is that the state is actually successful, and we don't want to include purchases that weren't successful. And we'll group by 1 and 2. Okay, take a minute to see if that looks right. And if I make a mistake, DBT will let me know. Finally, we're going to select star from that table I just built, items purchased. Okay, let's see if this compiles. Awesome. Okay, so we have a new table that we've built, has the item ID, the category, the total number of times it's been purchased, and how much has actually been spent on that particular item. We've now created a table that might be useful for your business to actually know which items are performing better or which ones are performing worse. And we're a step further from the raw data to actually be aligned with what the business needs. And here's our DAG of the new table that we've created. So once we feel good about that, we can commit our work. I'll call this new items purchase table. And we open up a pull request. This is the Git flow simplification that I was talking about. So now we're in GitHub, we can create our pull request. And one of the cool things about dbt is it has this like little check mark here. So it's checking to make sure that the code that I just created passes all of the tests that I've also set for my data models. I'm going to take a minute to actually show you what that looks like in dbt. So along with transformations, we also make documentation and creating tests really native as a part of the dbt project development work. And so let's take a look at this schema.file. Schema file is a config file where you can give your models descriptions, you can give more descriptions on individual columns, you can create tests, making sure an ID is unique and not null. You can also make sure that one of the values is an accepted value, and get a lot more sophisticated with just creating tests to make sure the data is as expected. And that's really important because we want to make documentation and tests a native part of the development and workflow when you're building data models. dbt makes it really easy to see all this visually too in a doc site. Here, it will describe all of your models. You can get a nice description of the table, the columns, what are the downstream dependents, what are the upstream dependents. You can see a nice DAG here as well. And so once you've defined and described everything within your dbt project, we'll get this nice doc site that gets generated as well. So one of the things that I've been doing behind the scenes is I created a CI job that will make sure that this new model that we're building passes all of the tests that I've described for my for my table that I've just built. And in this pipeline for GitHub, we see this little check mark from dbt cloud that says, yep, we've tested the data. There aren't any mistakes in it as you've described, and it's okay to go ahead and merge your pull request. Now, if your tests fail, you'd get an X here, and it wouldn't be possible to merge your new code into main. This creates a little bit more confidence. That way your data is building as you expect. But in this case, it is, so I'm going to merge it into my main branch. Okay, great. So once we finish building our dbt project, the next thing we have to think about is, well, how do we actually deploy that code on a consistent schedule? dbt cloud lets you do this with a few clicks as well. So we can see we have two environments set up for this project. We have a development environment, which we were just working in, and a production environment where our jobs are going to run on a consistent schedule. So if I look at my jobs, I have a production run job. And with just a few clicks, I can describe the commands of what I actually want this job to do. I want it to seed all of my data, run the full DAG, test that DAG, and it's going to run on a cron schedule every day at 9 a.m. This is really simple, and I can have lots of jobs to build certain models that I care about on different schedules. And now you don't need custom engineering work to put your code into production. Let dbt cloud do the hard work for you. And so these are the things that I think are really fundamental to understanding how DBT and DBT Cloud works. The last thing I wanted to showcase is there's also really great isolation built into DBT. So this is my cloud data warehouse. We're using BigQuery in this example. And when I'm in development mode, all of my tables are building in isolation under this DBT Schottenstein schema. So I can't possibly mess up any of my production workflow because everything is building in my own sandbox here. Yukon Analytics, these are my production tables. So with DBT, I'm able to create separation of environments within my data warehouse. So that way I can create dev environments for each of my devs, staging environments, so you can make sure that everything looks really great before you kick off those jobs in production. And finally, an area where these are really reliable tables that can be consumed by dashboards or other visualizations ready for your employees or internal uses. So that's it for the demo. In a really short period of time, we were able to show a bunch of cool things. One, how to do core DBT transformations with DBT Core, how to add documentation and tests to your models, how to look at CI, so that way when you merge code into your production main branch, you make sure you haven't introduced any mistakes, how to set up a job, and then how we create isolation between different environments and different developers in your warehouse. And that's it for the demo. We're going to head back to the slides to wrap up the presentation. There's one thing I hope you learned from the talk. It's that DBT isn't just software. It changes the way people work. With DBT at the center of your data stack, you can be sure your teams will be more collaborative, working faster, all while removing bottlenecks and shipping more reliable data. It's a fundamentally different philosophy on the way data teams think about data ops. One thing we strongly believe is the world needs more purple people. What do I mean by that? This metaphor paints a world where humans with a deep understanding of business context in a particular domain are called red people, and humans with a breadth of technical expertise are called blue people. Purple people are the people in between. They have a little bit of both that enables them to translate between red and blue. Analytics engineers are purple people and a critical Sherpa of guiding companies to the promised land where data actually helps teams make better decisions for the business. And we're well on our way to making DBT the standard. We have over 6,000 companies using DBT, over 1,000 customers, and more than 18,000 fantastic members of the DBT Slack community. We welcome you to join us. DBT Core is open source and free to download and get started. We also have a developer tier for our DBT Cloud platform, so any individual can try out the full platform for free. Some other ways you can get involved: join the DBT community Slack, subscribe to our Analytics Engineering Roundup weekly newsletter, listen to our podcast that our CEO, Tristan Handy, and myself co-host every other week. And lastly, we're hiring and we'd love to hear from you. And that's it for me. Again, I'm Julia Schottenstein from DBT Labs, and I'll be sticking around in Discord to speak with all of you. Next up, you'll hear from Max, who'll be talking about Superset. Thanks very much for listening.